Second learning objective, we're going to look at scenario analysis and other types of what-if analysis. You know you're doing scenario analysis if you see the words base case, or most likely case, best case, and worst case. So we're going to ask what if. What happens to the NPV if we increase the selling price, if we increase the quantity sold, if we decrease the cost? These are questions we'll ask. The base case is based on our best guess at the time, our initial set of projections, most likely case. You'll hear different terms for this, but generally we'll look at 3 different cases. We'll look at, and keep it to 3. Don't get into analysis paralysis by doing 15 different cases. 3 cases should be enough to bound your problem. Best case, base case, and worst case, sometimes called bull, bear, and base. In the best case, or the most optimistic case, your price and quantity go up and your costs go down. And the exact opposite in the worst case, smaller values, low values for price and quantity, and high values for cost. So this is the way we do, and this is when we know we're doing scenario analysis, when we have these words popping up: best case, worst case, base case. Once again, session 9 comes into play here. You have a positive NPV. That rule didn't change. We proceed with the project, and if we come out with a negative NPV, do not proceed unless we do a little bit more evaluation. But again, try and avoid that analysis paralysis. You'll spend all your time creating analyses, never making a decision. Scenario analysis can tell us what can happen, how to gauge for disaster, cannot tell us whether or not to take the project. You have to stand up and make that decision yourself. Second form of what-if analysis you've done in earlier years is sensitivity. You may have learned this in econ class. What happens to our NPV when only one variable is changed and we keep all the other variables constant? So if an NPV is sensitive to a small change in one variable, there's greater forecasting risk, and usually that's quantity or price. So those are usually your variables that are most sensitive to change. On this graph, we can see the base case, the best case, then the worst case, and the more sensitive your analysis is to that one variable, it will steepen that line more toward the y-axis. The steeper the line, the greater the sensitivity of the NPV to changes in the projected value of the variable. So steeper lines, more sensitive, be more careful. Sensitivity analysis can tell us which variable needs the most attention. Once again, that's usually quantity and price per unit, and cannot tell us what to do about possible forecasting errors. Finally, we combine sensitivity analysis and scenario analysis, and this was popularized around World War II. War gaming, we had computers that could assist us. We would change all variables in small increments up and down. And so do best case, base case, and worst case, combine that with sensitivity analysis, and you get what's known as a simulation analysis. You will generate hundreds and hundreds of variables, hundreds and maybe thousands of NPVs, and you can summarize these data by calculating the average of the NPVs, and then you still need to step up and make your decision. Simulation analysis can't tell us what to do with the results, and we also assume that all values are equally likely to occur. This may not always be the case, so take good care with simulation analysis.